Here's something that should stop you cold. The AI models being built right now are already helping to build the next AI models, and the researchers doing it just said so out loud. This week, Anthropic's Research Institute published a piece on recursive self-improvement, and the headline takeaway is blunt. We're not waiting for some future where machines design machines. That loop has quietly started. Think about what that actually means. Imagine a carpenter who builds a better hammer, and then that better hammer helps him build an even better one faster. Now imagine the hammer never gets tired, never sleeps, and gets sharper with every swing. That's roughly the shape of what's happening inside frontier AI labs in 2026. The engineers building these systems now use earlier versions of those same systems to write code, run experiments, and spot mistakes. The tool is helping forge its own successor. And the number that makes this concrete? Anthropic frames it as a measurable speed-up in research work, not a someday promise, but productivity you can already track. That's the part people keep missing. This story usually gets told as a far-off sci-fi worry. It's not far off anymore. It's a Tuesday at the office. Over the next few minutes, I'll walk you through exactly how this loop works, why one word, compounding, is keeping smart people up at night, and what Anthropic says it's doing to keep it safe. But here's the kicker, the speed isn't the scary part. Stick with me. To understand why this moment matters, rewind a bit. For most of computing history, humans did all the hard thinking and the machine just followed orders. You wrote every line of code by hand. The computer was a very fast, very literal assistant, brilliant at arithmetic, useless at judgment. Then large language models arrived, and something shifted. Suddenly software could read a vague request and produce working code, draft an experiment, or explain a tricky bug. Picture going from a calculator to a junior colleague who actually understands the problem. That's the leap we made in just a few years. Anthropic's own models, the Claude family, became genuinely useful for the people building AI, not as a gimmick, but as a daily tool. Researchers started handing off the tedious parts of their work, writing boilerplate code, running batches of tests, cleaning messy data. And here's the quiet turning point. The people whose entire job is to make AI better began using AI to do that job faster. That's the seed of recursive self-improvement. It didn't start with a dramatic announcement. It started with a researcher saving 20 minutes here, an afternoon there. Multiply that across a whole lab, across thousands of experiments, and the math gets interesting fast. One internal framing suggests these tools can meaningfully compress the time between research ideas. Small savings, stacked relentlessly, change the trajectory of an entire field. And this is where things get surprising, because the next step isn't just faster typing. Let's define the scary-sounding phrase properly, because most coverage gets it wrong. Recursive self-improvement does not mean an AI rewriting its own brain in a dark room while we sleep. The reality is more grounded, and honestly more interesting. It means AI systems helping to improve the process that produces the next AI system. Think of building a model as a long assembly line. There's designing the architecture, writing the training code, running experiments, analyzing results, and fixing what broke. Today, AI can already take real chunks of that line. Anthropic draws a sharp distinction here. There's a huge gap between an AI that writes a snippet of code when asked, and an AI that can run an entire research loop on its own. Picture the difference between a smart intern who completes tasks you hand them versus a researcher who comes up with the question, designs the test, runs it, reads the results, and decides what to try next. We are firmly in the intern stage, but the intern is getting promoted. The word that matters is compounding. If each generation of AI makes the next generation, say, 10% easier to build, that gain doesn't just add, it stacks on top of itself, again and again. That's the same math that turns a small savings account into a fortune over decades. Slow at first, then startling. And here's the twist nobody expected. The bottleneck isn't intelligence at all. It's something far more stubborn, and we'll get to it. So what does this actually look like on the ground, in a real lab, in 2026? Let's get specific. A machine learning researcher wants to test a new idea for making a model train more efficiently. In the old days, that meant hours of handwriting the experiment code, double-checking it, then babysitting the run. Now, that researcher describes the idea in plain language to an AI coding assistant. The assistant drafts the experiment, flags a likely bug before it wastes compute, and suggests two variations the human hadn't considered. The researcher reviews, tweaks, and launches in a fraction of the time. Multiply that across a team. One person's good afternoon becomes the whole lab's good week. Anthropic points to exactly this kind of work, AI accelerating the messy, time-consuming middle of research, not the flashy headline moments. Here's a concrete way to feel the scale. If a tool saves each researcher even 1 day a week, a team of 100 just gained 2,000 extra working days a year out of thin air. That's like hiring a small second team that costs almost nothing, and the assistant keeps improving because the next model is better at exactly this. But there's a catch worth naming. The AI is brilliant at the parts that look like code and patterns, and still shaky at genuine scientific taste. Knowing which question is worth asking at all, that judgment still lives with humans, for now, and that gap is precisely where the real story starts. Now let's separate the breathless hype from what Anthropic is genuinely claiming, because the two are wildly different. On one side, you've got the loud internet take. AI is about to recursively explode into a superintelligence overnight. Boom, game over, nothing we can do. Dramatic, clickable, and mostly wrong about the timeline. On the other side, you've got the dismissive take. It's just fancy autocomplete, nothing's really changing, calm down. Also wrong, just in the opposite direction. Anthropic's actual position sits in the uncomfortable middle, which is exactly why it's worth taking seriously. Their framing is measured. Real, measurable speed-ups in research are happening today. The full self-driving research loop is not here yet, but the trend line is pointing up, and they'd rather talk about it early than get surprised late. Compare it to self-driving cars. For years, we had driver assist features, lane keeping, smart cruise control that genuinely helped, while full autonomy stayed stubbornly out of reach. AI research is in that driver assist phase right now. Very capable co-pilot, humans still firmly behind the wheel. The difference? With cars, the car can't help design a better car. Here it can. That's the line that makes this category genuinely new. One side says the explosion already happened. The other says nothing's happening. The truth is quieter and more unsettling, a steady, compounding climb that's easy to underestimate precisely because no single week feels dramatic. And here's what the headlines aren't telling you about why a careful lab would publish this at all. Here's why a company would publicly raise a topic that sounds alarming, and it comes down to one idea. If progress compounds, then the time you have to prepare shrinks every single year. Let me make that tangible. Imagine a flu that doubles its spread every week. In week 1, it's a handful of cases, easy to ignore. By week 10, it's everywhere. Nothing about each individual week felt dramatic, yet the curve was always steep. Compounding technology behaves the same. The danger isn't a sudden robot uprising. It's that capability could arrive faster than our safety work, our laws, and our institutions can adapt. Anthropic's whole pitch is that you have to build the brakes before the car is going 100 miles an hour, not after. That means investing now in alignment, the field of making sure these systems actually do what we intend, even as they grow more capable. And there's a deeper worry tucked inside the loop. If AI is helping build AI, a small flaw or blind spot could get baked into the next generation, and the one after that quietly amplified each cycle. A tiny error compounded becomes a structural one. That's why transparency matters so much here. A lab saying out loud, "This is happening, here's our progress, here are the limits," that's the opposite of a secret arms race. The part most people overlook entirely is that publishing this early is itself a safety move. So what can you actually do with all this? Let's get practical. You don't need a research lab to follow this story intelligently, you just need to know what to watch. Let me give you a simple framework. First, track capability, not hype. Ignore the dramatic predictions and watch for concrete, measurable claims. A lab saying a tool cut a specific task time by a specific amount. Real numbers beat big adjectives every time. Second, watch the loop tighten. The signal to look for isn't smarter chatbots. It's AI taking over more of the actual research pipeline, designing experiments, not just writing code. When a lab reports AI running a full experiment start to finish with light supervision, that's a genuine milestone. Mark it. Third, follow the safety side as closely as the capability side. When a company publishes its limits and its safeguards openly, like this Anthropic piece, that's a healthier signal than silence. A field that talks about its risks is one that's at least trying to manage them. Fourth, and most practically, Get hands-on yourself. Use the AI coding and research assistants that exist today. Nothing builds real intuition like watching where they shine and where they fall flat. You'll quickly feel that gap between a clever assistant and a true autonomous researcher, and you'll understand this whole debate far better than someone just reading headlines. Set a simple habit. Once a month, ask one question. Can these tools do something today they plainly couldn't last year? Track your own honest answer over time. That trend line will tell you more than any forecast. And that brings us to the one thing you should take away. So here's what this actually means for you going forward. The era where AI helps build AI isn't a prediction anymore. It's a quiet, measurable reality, and the most credible voices in the field are telling us the curve only gets steeper from here. The single takeaway I want you to hold onto is this. Watch the compounding, not the noise. The headlines will swing wildly between it's the apocalypse and it's all overblown. The real story lies in the boring middle, small, stacking gains that don't look dramatic in any single week, but quietly bend the whole trajectory of technology. That's the thing to respect. Anthropic's message, stripped of jargon, is refreshingly honest. This is happening, it's powerful, it's not magic yet, and the responsible move is to prepare while there's still slack in the system. Whether you're a developer, a student, or just someone who wants to understand the world you're living in, the smartest position is curious and clear-eyed, not panicked, not dismissive. Start using these tools. Learn where they help and where they stumble. Build your own sense of the pace, because that instinct is about to be genuinely valuable. The labs are racing to build the future. You don't have to just watch it happen to you, you can understand it as it unfolds, and that understanding is real power. If you want to keep up as this loop tightens, this is the channel for it. Follow for daily AI news, and I'll keep breaking down what actually matters. I'm Riff, I'll see you in the next one.